Okay boys, so this type of question is to do with acceleration from a graph, specifically a velocity time graph. Velocity time graph. On a velocity time graph, to find the acceleration you need to find the slope. Okay? So, in this question, it's asking for how much is the acceleration. So let's find the slope. Okay boys, so this question's about acceleration, but it's using a graph, a velocity time graph, instead of the numbers that we were dealing with before. It's the same method to find the acceleration. We have to use our formula. Our formula triangle for acceleration, if you remember, is acceleration on the bottom, time on the bottom, and change of speed on the top. You've got final speed in meters per second minus initial speed divided by acceleration times time. If you want to find acceleration, you cover up acceleration and you get s final minus s initial divided by time. We can even write that down here. Acceleration is s final minus s initial divided by time. So those are the numbers we need to get from the graph. 3 numbers to find acceleration. We need to get the speed final, the speed initial, and the time. Now from this graph, the speed is written here. You can see meters per second, here, along the side. The time is written along the bottom. So we need 1 time and 2 speeds. The final speed is going to be at the end of the graph, and the initial speed at the beginning. So the initial speed is easy, it's 0 meters per second. The final speed is a bit difficult because it's about, let's say, there, which is just above 8. You think that's 10, we'd say it's about 9 here. 9. So we've said that the starting speed, the initial speed, was 0. So this one was 0 meters per second from the graph. And we said that the final speed was about 9 meters per second from the graph. Now we just need the time from the graph. So the time here is along the bottom. We would take the time from these numbers here. And since the graph ends about here and starts there, the time is about 6.8 seconds. Nearly 7 seconds. So we could write here almost 7 seconds, about 6.8 seconds. Now we have all the numbers we need to find the acceleration. We put in the numbers, 9 minus 0 divided by 6.8, and you then put in the calculator and you get an answer. That answer, I'll leave it as a fraction since I don't have a calculator with me, but that answer will give you the acceleration in meters per second squared. Don't forget the units. Now, one last step. If the slope is going upwards like it is in this example, then you'd put a plus. If it was going downwards, you'd put a minus. So as you can see here, this acceleration will be a plus, positive, because the slope is going up. Okay, remember, if it was going down like this, it would be negative. This is a positive. Let's see if you can solve this graph. Could you find the acceleration for this one? You should have started with this equation, of course, from your triangle. Acceleration is speed final minus speed initial divided by time. So those are your 3 numbers you need to find from the graph. Speed final, where the speed finishes, is about there. And remember, that's the time, so you're going to get the speed from this side, about 2. The speed initial, about 12. So 2 minus 12. And then we need the time. Well, the time is written along the bottom, and it starts here at 0 and it moves to 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds. So I'm going to cut it off at 5, just about 5 point something. The time is about 5 point. So there's your numbers, the three numbers from the graph. You've got the acceleration equals 2 minus 12 divided by 5. So it equals 2 minus 12 is minus 10 divided by 5. That equals minus 2 ms squared. Notice there's a minus here, so you're expecting the graph to be going down like this. So let's check if that's the case. And yes, that is the case. For this final graph, we have a straight line. And if you remember, a straight line means the same velocity. The velocity is actually staying here at 2. So we're not expecting any acceleration. The acceleration we should find is 0, because it's the same speed. And acceleration means a change in speed. If the speed is not changing, it's staying at 2, that means there should be no acceleration. So let's use the formula and see if that's the case. Again, we remember our formula for acceleration. Speed final minus speed initial divided by time. We need to find these three numbers from the graph. This time we're going to start with the time. So the time for this graph starts at 0 and it goes 1, 2, 3, 4, 5. Let's say about 5 seconds. So there we go, we added 5 seconds for the time. Now we need to find speed final and speed initial. Well, the speed final on this graph here is, remember the speed's always on this side, the number's on this side, so the speed when it's here is 2 meters per second. And the speed at the beginning is also 2 meters per second. So now we have our three numbers. And we just need to work out what they give us. So we have 2 minus 2 divided by 5. 2 minus 2 is obviously 0. Divided by 5, if you put anything in the calculator with a 0 on the top, 0 divided by anything, it will give you the answer 0. You can't divide 0. You can't divide nothing. So the answer is 0. And don't forget the units. ms2. So yes, correct. As we expected, the acceleration is 0. Because it's a constant speed.